Good day, ladies and gentlemen. I'd like to go backwards today for just a bit and take a look at types of solutions and classifications, which was the end of equation solving right before we actually began to investigate repeated addition patterns. In order to do a little more advanced equation solving, we started to investigate, or review, I should say, the number sets that you had been studying since second or third grade. The first number set that you've been accustomed to, or that you're introduced to, were the counting numbers, and the counting of the natural numbers start at 1 and go up to infinity. And we've said in the past that when we added 0 to the counting numbers, it was really quite fascinating because the idea that there's a number that represents nothing took a while for mankind to interpret and understand and actually create. When you take the whole numbers, which start at 0 and go out to positive infinity, they don't include any partial values because they're whole numbers. There won't be any decimals or fractions. And you add the opposites, you get the integers. So it's quite often that a question that we'll solve will ask for an integer solution. And if we're looking for an integer solution, we should know that since we're considering the whole numbers and their opposites, there shouldn't be any partial values, neither positive nor negative, no decimals, no fractions, when you're asked to determine an integer solution. Many times we'll be asked to find a rational solution, and rational means fractional. And we have to be careful about how that's interpreted. Because if we're asked to find a rational solution, it is possible that we could have an integer. You could have a number, say, like 3, because 3 is an integer, and 3 is also rational. Rational means fractional, so if we wanted to make 3 into a fraction, we could put it over 1. Or 3 could be in disguise in many other ways, such as 12 fourths. 12 divided by 4 is also 3. So there are many ways to describe 3 in a fractional expression where its value would actually equal 3, but it would appear as a fraction to us. Rational meaning fractional is just a quick little reminder. It's never a definition. What really means rational are numbers that can be written as fractions, and those should be either terminating or repeating decimals. So if you have a terminating or a repeating decimal, we can write that as a fraction, such as 25 hundredths. We should know that 25 hundredths is equal to 25 out of 100. And furthermore, we should know that we can simplify that by dividing out a GCF of 25. And if you divide 25 out of the numerator and denominator, technically you're just dividing by 1, because 25 divided by 25 is 1. And any amount divided by 1 would equal itself. So by dividing by 1, we get an equivalent form of 1/4. And you guys know that. You know 25 hundredths is equal to 1/4, especially when we're dealing with money. That is a terminating decimal. That value stops. It doesn't continue on and on and on. And all terminating decimals can be written as a fraction. In addition, repeating decimals such as 1.33333333 repeating can also be written as fractions, which I hope to show you in just a bit. 0.333 repeating is 1/3. And there are ways that we can get our calculator to perform those transformations for us, and we'll take a look at that in just a moment. If rational means fractional, well, technically all numbers can be written as fractions, which include terminating and repeating decimals, that stands to reason that irrational would mean non-fractional, or numbers that cannot be written as a fraction, and that would include the opposite of terminating and repeating decimals. That would be non-terminating and non-repeating decimals. The most popular such number is pi. We see that often in a lot of our work. Pi is 3.14159, and we've gone over why we can't write this as a fraction, because on forever and doesn't repeat, therefore we can't read the decimal appropriately, and we don't know what denominator to put the decimal portion of the relationship or the quantity. We've tried to write pi as a fraction before in class, and I've suggested that maybe it's 3 and 1/10, and we said, no, that's not representing enough of the number. So we said, how about 3 and 14 hundredths? We said, that still doesn't do it. And I believe we've agreed that this process will go on forever, and we can never appropriately read the decimal portion of the number. Therefore, we can never properly put it over the correct denominator, and it cannot be written as a fraction. All non-perfect squares do the same thing, and we do a lot with non-perfect squares towards the second half of the course. So it's important that we understand that if you're taking the square root of a number that's not the result of that's a number times itself, then it would be a non-perfect square. And non-perfect squares will always give us non-terminating, non-repeating quantities or irrational amounts. I often say that if your mom is being irrational, she'll come in and she'll suggest that she's upset that you left your socks out. And then she'll say that she doesn't like your friends and that your soap is smelly and all kinds of stuff. And she'll go on and on and on and won't really repeat anything. It just won't make any sense. And that's kind of what irrational numbers do. When you combine the rational and irrational numbers together, you get most of the types of solutions we work with in this class, which are the real numbers. The real number system is what we do a majority of our work in. All rational and irrational numbers, all terminating and repeating decimals, as well as non-terminating, non-repeating decimal values. Towards the end of the year, we'll talk a bit about the complex numbers or the imaginary numbers. And the imaginary numbers are a result of trying to take the square root of a negative. You can't take the square root of a negative in the real number system because square root asks what number times itself equals a negative. And the last time I checked in our number system, in order to get a negative product, you have to have a positive times a negative, and those numbers would not be the same. So we will take a look at imaginary complex numbers later in the year, but for the most part, we work in the real number system, all rational and irrational numbers, which obviously include the integers, the whole, and the natural numbers, because integers, whole, and natural numbers are all rational amounts that can all be written as a fraction by putting them over 1 or having some other equivalent form of the expression. It's important to understand that there's a big difference between dividing by 0 and dividing into 0. Dividing into 0 says how much of, say, 8 goes into 0, and the answer is none of it. None of 8 fits into 0. So 0 divided by 8 is in fact 0. That's totally different than when you divide by 0. When you divide by 0, you're asking how much nothing can you fit inside of an amount. How much nothing fits inside of 5? And I'll always use the example where I'll say, hey, if I asked you to bring nothing from my car in the parking lot into the classroom all day, and I wanted you to do that until you filled the classroom up, how long could you do that for? And the answer is beyond infinite. You can never stop. You can never bring enough nothing into a room to fill it up. Therefore, when you ask how much nothing fits inside of 5, it's indescribably large. Some might say beyond infinite, and therefore we say it's undefined. There's no way really to describe how much that would be. If you take a look down at some of the examples that we did for homework, where we're asked to identify which of the expressions simplify to equal whole numbers. Whole numbers are starting at 0. We kind of remember that because the word whole has an O in it, and they go up to infinity. And in order to determine if these values are whole numbers, you should evaluate them in your calculator. If you were to evaluate them in your calculator, it's really kind of simple. I'll reset mine. Second, access to memory, choice 7, reset, enter. And to divide 12 by 0, I'd have to type the numerator first, divided by 0, which should be really awkward because we're asking how much nothing fits inside of an amount. And when I hit enter, my calculator freaks out. It says error, dividing by 0. Cannot be divided by 0. So it's letting me know that there's a problem there, and that's because the value is undefined and it's unable to evaluate it. Negative 12 is not a whole number. Whole numbers start at 0 and go to positive infinity. 12 6, if you would divide it in the appropriate order, 12 divided by 6 is in fact 2, and therefore that is a whole number. The square root of 144, square root is above the x squared key, so you'd have to do second function, square root 144. And when you determine what number times itself equals 144, it is 12, so that is a whole number in disguise. 6 divided by 12 must happen in that order, and 6 twelfths is actually 0.5, so that is not a whole number. The square root of 12, if you were to evaluate it, what number times itself equals 12, is not a perfect square. It's a little less than 3.5, but that decimal goes on forever and doesn't repeat. That's an irrational quantity, which is certainly not a whole number. Whole numbers do not include any partial values, so as soon as the decimal shows up, we know it's not a whole number. This happens to be irrational. If you actually asked your calculator to turn into a fraction, you said math, choice 1, turn into a fraction, it would spit out the same decimal value because it can't make a fraction out of it. It's like, I don't know, I can't read the end of this. The end does not at the end of this number is not at the end of the screen. The calculator's just been programmed to show 10 decimal place values, and it's kind of getting bored. So it's rounding the last one. When you divide 0 by 12, you ask the question, how much 12 fits into 0? The answer is simply 0, and that is a whole number. If you were to move on to the second set, and you're asked which of the values are integers, you're looking for the whole numbers and their opposites. The square root of 8 is irrational. It goes on forever and doesn't repeat if you evaluate that in your calculator. Negative 4/8 is equivalent to negative 1/2. That is not an integer. The integers are the whole numbers and their opposites, no partial values. So although it's negative, that's not what integer means. Integer simply means the whole numbers and their opposites. Whole numbers have no partial values, therefore neither do the integers. Square root of 64 is 8. That would be an integer. 0 never divides into 8 or divides to it so infinitesimally large its value is undefined, therefore not an integer. 8 fits into 0 0 times. 0.8 as a decimal, when we read that appropriately, is 8/10, 8 out of 10. That would not be an integer. Integers are the whole numbers and their opposites, no partial values, no decimals or fractions. And negative 8/4 is negative 2 in disguise, and that is in fact an integer. Down below, when you're asked which are rational, rational means fractional, more appropriately means a terminating or repeating decimal. So we see something like 0.4 repeating, we should know that that is going to have a rational presentation. And if you were to look at it on your calculator, you could actually go to your screen and trick your calculator into believing that you have a repeating decimal by typing a bunch of decimal 4s, 0.44444 across your screen, then going math, turn it into a fraction, choice 1, and your calculator will be like, oh, 0.4 repeating is 4/9. So it shows you that a repeating decimal is rational. Rational means fractional, but more importantly, it's any terminating or repeating decimal that can be written as a fraction. When you go back and you consider what 1/4 is equivalent to, obviously that's rational. It's written as a fraction, so it must be a fraction. It's equal to negative 25/100 in decimal form. When you ask your calculator what the square root of negative 4 is, it freaks out because you're asking what amount times itself equals a negative, and there is no such amount in our number system, so it says no real answer. The real numbers that we work with are rational and irrational quantities. As you continue, you can take the opposite of the square root of 4. That's just the opposite of 2, which is negative 2. And if you ask your calculator what the square root of 40 is, let me quit out of this. What number times itself equals 40? And kids will have to say, 2, that's easy, man, that's 20. No, square root doesn't say what number times 2, it says what number times itself, and that comes out to a non-terminating, non-repeating decimal. That would be irrational because 40 is not a perfect square. If you ask your calculator to turn it into a fraction, math, choice 1, it spits out the same decimal because it's unable to. Cool. Knowing the definitions of the number sets we use is incredibly important because you often get instructions when you're evaluating an expression where it'll ask you, is it an integer? Is it rational? Is it a whole number? So in Roman numeral 4 on this particular assignment, we were asked to evaluate these expressions, which you should remember from 6th grade, following order of operations PEMDAS. It wouldn't be wrong in this particular class to use your calculator to help do a lot of these computations. But if you're following order of operations and you begin within the innermost parentheses, and then you evaluate the exponent, and then you continue to evaluate the grouped quantity appropriately and take 1/5 of the value, 17/5 is a rational quantity. It is not an integer. So if we're looking for integer, that would not be correct. Integers are the whole numbers and their opposites. We wouldn't select that. In letter B, if we're following order of operations, we would begin inside the parentheses with subtraction. We would square that value. We would eventually divide. And once again, when we get 25/6, that is not an integer. That's a partial value. That would have a decimal presentation if we were to perform that division. And in the last expression, the absolute value of 9 less 4 is just 5. When we square 3, we get 9. When we perform our multiplications and subtract, we get -18. And there's your integer value. Integers are the whole numbers and their opposite. They do not include partial values. When you're solving an equation and you're asked to find a non-integer rational solution, integers are the whole numbers and their opposite. So non-integer would be a decimal or a fractional quantity without a denominator of 1. If we're looking for a non-integer rational solution, we would begin by putting up a fence, distributing in either expression if we can, transferring a variable, solving a two-step equation, and when you divide 4 by 8, you get a half. And that is, in fact, a non-integer rational solution. Rational means a number that can be written as a fraction, and when you have a partial value, that would be a non-integer solution. And we can check our work. In B, put up a fence, solve appropriately, x is 2. That is an integer. It doesn't mean it's not rational because you can write it as 2/1, but it's not a non-integer rational solution. So that's not actually what we're looking for this particular skill set. In C, when you transfer a variable and solve a two-step, you get -18/7. That would have a decimal quantity to it, or we could leave it in fraction form. So that would be a non-integer rational solution. And we can check our work, which we'll investigate in just a minute. When you're solving equations, these are technically linear equations, by the way. There's just no y in them. They're linear because they're x to the first. So they're really kind of simple to work with. When you're solving with a single variable x, you're trying to find the value of x at this particular point in time. And to do that, we often begin with distribution. We try and clear parentheses, regardless of how difficult the relationship is to interpret. Then, if we have any fractional quantities, we choose to undo the denominator, the division with multiplication. You can multiply an equation by whatever you want, as long as you equal on both sides. We simplify both expressions if we need to, transfer a variable, and solve a two-step equation. For this particular question, you were asked to find a negative. Ooh, I like that. My answer is negative. Rational. Rational means fractional. I like that. Non-integer means I can't simply divide it by 1, or I don't simply have a denominator of 1, I should say. And that's what I got. And I was able to check my work by getting pretty crafty with my calculator and substituting in that fractional value into each expression and evaluating them separately to get the appropriate answer. Let's take a look at some practice questions together. So if you were to take a look at types of solutions classification day 2, there's a review of the number sets, and then you're asked to solve this equation in Roman number 1 to get a positive integer as your answer. So in order to get a positive integer, obviously the value of x must be positive, and integer means there shouldn't be any partial value associated with it. There shouldn't be any decimal or fractional quantity when we're done solving. To begin solving, you'd have to put up a fence to separate the expressions, and I would recommend distributing or clearing the parentheses. In the expression on the left, we want to triple x plus 4, which technically means we have x plus 4 3 times. But in order to perform tripling x plus 4, we suggest that you distribute. You share that multiplication of 3 into the grouped quantity, and do the same thing in the expression on the left. If you're confident, you could pause the video at this point and see if you're able to get the appropriate solution on your own. Give it a shot. Assuming you took a moment to solve the equation, I hope that when you tripled x plus 4, you got 3x plus 12, and when you multiplied -5 times x less 3, you got -5x plus 15. -5 times -3, negative times a negative is a positive. In the expression on the right, you should collect like terms. 15 less 19 is -4. And then I'd recommend that you transfer a variable in the next step. I prefer to transfer the variable with the lower coefficient. It leads to having to work with less negative signs. So my preference would be to undo the -5x by adding 5x to both expressions. It's not the only way to do it. So long as you use the additive property of equality appropriately, you can add whatever you want to an equation so long as you do it equally on both sides. I find this most efficient. I'm then solving a two-step equation. I'm going to begin by subtracting 12 from both expressions and dividing by 8, and I get x is -2. I hate that I got x is -2 because I thought I was solving for a positive integer, but maybe I wrote the question wrong. So let me check it and see if we got it right, or if I have to go back and figure out what I did wrong. So I'm going to check that x is -2, and we don't do this enough. To check your relationship, folks, you're going to substitute using parentheses. Is it true that triple -2, so I'm going to use a set of parentheses to enclose -2 as well as the parentheses I need for the grouped quantity with +4. And then I'm going to write -5 times -2 less 3, close out the grouped quantity, minus 19. And all you really have to do, and especially when you work with delta, you should check your work before you hit enter, is evaluate each expression on your calculator. So to do that appropriately, I'm going to clear out my calculator screen. and type in triple the grouped quantity, open set of parentheses for -2, close the parentheses off, plus 4, and the expression on the left should equal 6. I'm going to type in the expression on the right, -5, open parentheses for the grouped quantity, second open parentheses to substitute in -2, close off -2, subtract 3, close off the grouped quantity, and subtract 19. Decrease that by 19, and hopefully it says 6. Okay, so I'm super psyched because it turns out I actually just wrote the question wrong. The question said find a negative integer, because clearly the result is negative. X is in fact -2. That is the value that would make the expression on the left equal to the expression on the right. So this should have said find a negative integer solution. As we move on down, there's a similar style question. And I'm going to get you started, and then I'll ask you to pause the video and give it a shot on your own. In Roman numeral 2, you're asked for the given equation to find a positive rational non-integer. So hopefully it's going to be positive. Rational means fractional. Non-integer means we should have a denominator other than 1. That way, if we were to try and simplify the solution, we would get some partial value or decimal associated with it. If you were to try to solve this, I would suggest that you put up a fence. And one of the most difficult things to recognize here is that you're subtracting the entire grouped quantity 2x less 6, so you have to distribute the -1 to make sure that you subtract 2x and -6, which can be a little tricky. If you'd like, you can give the video a pause and see if you're able to do that on your own, and if you're happy with your result. Assuming you gave Roman numeral 2 a shot, remember that we're looking for a positive rational non-integer, and we'll often be given instructions, and those instructions will help us to determine if we're happy with our solution. So I began by distributing -1 into the grouped quantity. When I'm subtracting 2x less 6, I'm subtracting 2x, obviously, but I'm also subtracting -6. Subtraction is the same as adding the opposite, so when I perform that multiplication, it actually comes out as increasing the expression by +6. When you collect like terms, 8x less 2x is 6x's, and when you solve a two-step equation, you get 6x equals 4, and when you divide out the coefficient of 6, you end up with 4 divided by 6. If you perform that division, you're going to get 0.6 repeating, but that's really an elementary presentation of that answer, so we'd prefer that you leave it in fraction form. Either leave it as 4/6, or, especially with delta, if it says to put your fraction in simplest form, divide by 2 to get 2/3. If that's tricky for you to get simplest form, you can go to your calculator, and in your calculator, you can type in 4 divided by 6, and you can ask your calculator to simplify that expression by going to Math and choosing choice 1, turn into a fraction, and it will automatically turn into a fraction in simplest form. So that can be super helpful. It can also be super helpful because you might want to check your equation, and you might want to use some of the calculator function keys to help that go a little quicker. In checking your equation, you need to evaluate both expressions and see if they're similar. So the expression on the right is simply 10. The expression on the left is the one that needs simplification. The easiest way to do it is to just go to your calculator and type it in. If you need to do 8 times 2/3, you could do 8, and you could do grouped quantity 2 divided by 3, or you could use a fraction key, which I'll remind you of in just a moment. We're going to subtract out the group quantity twice, and again, we need 2/3. This time I'll use my fraction key to remind you where it is. Alpha, F1, that brings up my cheat tab, and the very first cheat is make a fraction, and I have 2 divided by 3. Close off, oh, sorry, I lost my coefficient. Let me just scroll over and type that in 2. Grouped quantity, substitute using parentheses, scroll out 2/3, -6, close off the grouped quantity, and hopefully when I hit enter, the expression on the left equals 10. Perfect. Because the expression on the left is equal to 10, that means that 2/3 is the value of x that would make the equation, that would solve the equation where, when substituted, both expressions are going to equal one another. X is in fact 2/3, a positive non-integer solution. I'm going to skip the conversion of turning a repeating decimal into a fraction, which is really cool, but we can always come back to it. You should know that rational means fractional. You should know, more importantly, that the numbers that can be written as a fraction are terminating or repeating decimals. And this is the really cool way that mathematically we're able to turn a repeating decimal into a fractional quantity. When we have more time later in the year, I'll try and come back to it. I would like to finish with Roman numeral 4, which asks us to determine which of the equations has a negative rational non-integer solution. So obviously we're looking for which of them has a negative sign associated with it. Rational means fractional, and non-integer means there's going to be a partial value associated with it. If you want to think of it in a little less mathematical terminology, you could say, Tooch, am I just looking for a negative fraction? Yeah, you are, but technically you're looking for a fraction without a denominator of 1. But if you think of it as a negative fraction, that's fine. In relationship A, or equation A, you'd put up a fence. You'd begin by distributing, tripling 2 and 52/100 increased by 4/10x, and quadrupling half x plus 6. And then you continue to solve. Pause the video and give it a shot. Assuming you paused appropriately, When you triple the expression on the left, you get 7 and 56 hundredths, increased by 1 and 2/10 x. And when you quadruple the expression on the right, you get 2x plus 24. I would recommend transferring a variable at this point, and I would add the opposite of the variable term, the algebraic term, with the lower coefficient. So my preference would be to subtract 1 and 2/10 x from both expressions. It's not the only way to proceed. You could have added whatever you wanted or subtracted, as long as you did it equally in both expressions. As you continue, you end up at a two-step equation where you'd have to subtract 24 from both expressions, or that would be my preference at least. And you end up with 16 and 44 hundredths is equal to 8/10 x. I apologize for the penmanship. When you divide out the coefficient of 8/10 in both expressions, the final answer suggests that x should be negative 20 and 55 hundredths. Negative 20 and 55 hundredths is certainly a real number. It's certainly negative. And in addition to that, it is a terminating decimal. That would make it a non-integer rational solution, a negative non-integer rational solution. If you took a moment to check your answer, you'd have to substitute negative 20 and 55 hundredths in place of x in both expressions. Typing that into your calculator, you'd want to be sure to substitute using parentheses negative 20 and 55 hundredths in place of x in both expressions. I actually got it wrong the first time because I didn't copy correctly. So if I had substituted appropriately and evaluated, the expression on the left should have equaled negative 17 and 1/10, and the expression on the right comes out to the same amount, which means that I did it correctly, and if this were delta, I could input my solution. For relationship B, in the equation that we've been given, it's often a good idea when you're solving an equation and you're able to distribute or clear parentheses if there's any such multiplication in the relationship. In the expression on the left, we're asked to multiply 5 times the quantity x plus 1, which you get as 5x plus 5. And that's going to be equal to, in the numerator, negative 3 times 2 less x. So in the numerator, when I distribute it, you get negative 6. Negative 3 times negative x should be positive 3x, and that's all being divided by 2. We should recall that when we're solving an equation with fractions in it, we'd like to undo the denominator. Fractions have denominators, and denominators mean divide. So ideally, we would like to multiply the expression on the right by 2. We can multiply an equation by whatever we want, as long as we do it equally on both sides. So if I'm going to double the expression on the right, I should also double the expression on the left, and that means all the terms, the 5x as well as the 5. When I do that appropriately, I'm left with 10x plus 10 is equal to, and in the expression on the right, some people might choose to distribute the 2 into the numerator because technically we're multiplying by 2 over 1, but I like to simplify before I multiply. So I'm going to actually divide 2 into itself once in the denominator and in the numerator, and then I'm just going to have to distribute 1 into the grouped quantity. And I'm left with negative 6 plus 3x. Anything times 1 is just itself. And technically we're dividing by 1, but I don't need to show that because anything divided by 1 is just itself. So I've cleared the denominator. From there, the steps should look familiar. You need to transfer a variable and solve a two-step. Give it a shot and see what you get. There are many correct ways to solve at this point. My preference is often when I'm transferring a variable, when I have variable terms in both expressions, to add the opposite of the variable, the algebraic amount with the lower coefficient. So my preference would be to subtract 3x's from both expressions, then undo addition with subtraction when I solve a two-step equation, and undo multiplication with division. So I'm going to divide both expressions by 7, and I'm left with x equals negative 16 sevenths, which is pretty cool because that is also a negative non-integer rational solution. So they both have appropriate solutions for what we were looking for in this particular skill set. It's a good idea to check your work at this point, and if you were to take negative 16 sevenths and substitute that in using a calculator, you could evaluate each expression to see if they come out equivalently. I chose to use the fraction key when I evaluated both expressions with negative 16 sevenths as my solution because it got a little bit crazy in some of the substitutions. For the expression on the right in the numerator where I had to do 2 minus negative 16 sevenths, it just felt a lot easier to put that in as a fraction within my fraction. So I'll retype that for you just a moment. In the expression on the left, it just seemed like less confusion when I had to substitute using parentheses to multiply 5 times negative 16 sevenths plus 1 and ultimately get the same value in each expression, knowing that I got it correctly. I'm going to retype the expression on the right. That way you guys can see how that was done. I chose to use my fraction key by going alpha F1, numerator denominator. I began with negative 3 in the numerator. I created a grouped quantity with an open parenthesis. I had 2 minus, and then I needed another fraction. Now, technically, I should have substituted using parentheses. Parentheses, create another fraction, alpha F1. Substitute in negative 16 divided by 7. Scroll out of the denominator, close off my substitution, and close off my grouped quantity. And in the denominator, I simply need to scroll down and type in 2. And that's how you would evaluate that more complex relationship. Ladies and gentlemen, this is the lesson on being able to solve more complicated equations and to be okay with getting non-integer rational solutions. We're not really going to get any irrational solutions yet, but these are the ones that we have to become very familiar with. Hope that you did well, and I'll see you in class. Take care.